In this demonstration, we'll discuss routing and forwarding tables with Juniper devices. The first thing to note is that there's two different types of forwarding tables. We have what's called a layer 3 forwarding table, which is going to contain the best routes that are flagged as active from the routing tables of the device and then added to the layer 3 forwarding table. We also have layer 2 forwarding tables. Layer 2 forwarding tables are found on switches or X series devices, and they're all about the MAC addresses and the interfaces where those MAC addresses can be found. So the way this works is, let's draw a little picture here. The idea is that you'll have your layer 2 device, like a switch. That switch will have a number of systems connected to it. Let's say, so we have 3 systems connected to it. Now the switch will have what we'll call a forwarding table. And that forwarding table will contain information such as, here's computer A, there's computer B, and this is computer C. And we'll say that computer A is plugged into port 1, computer B is plugged into port 2, and computer C is plugged into port 3. So what happens is that when a system first sends traffic out on the network, the Juniper device receives that traffic and it looks at the source MAC address of the packet. And it records, oh, so we've got the source MAC address of computer A plugged into port 1. And then that traffic goes and reaches the destination. Now, how it reaches the destination is, let's say computer A is going to send data to computer B. So the data comes up, hits the device looks at the source MAC address, and at that point records the source MAC address in the forwarding table. So as we mentioned, it records the fact that computer A is sitting in port number 1. Then what it does is it looks at the packet and says, okay, I need to send this over to this MAC address, and it's the MAC address of computer B. So it then looks in the forwarding table to locate the MAC address for computer B. The problem is the MAC address for computer B doesn't exist in the forwarding table yet because computer B has not sent traffic on the network. So at this point, what happens is the packet is flooded, right? Flooding means that the device will then send the packet to every port on the device. And the idea is that it's hoping to find the device. So what happens is the packet gets forwarded down here, it hits computer B. Computer B looks at the destination MAC address, says, oh, that's for me, and it sends a reply. Whereas any other devices, right, on the network, like computer C, the packet comes down, hits computer C, and at this point, computer C looks at the destination MAC address, says, oh, that's not for me, so I'm going to discard this message. So that's very important to understand. Flooding, we call it, is when the device doesn't know where that destination MAC address resides, the device then goes and basically sends the packet to every port on the device itself. So that's what's happening when a new packet arrives at the device. So that's kind of here in the slide. New packets, devices add MAC addresses to the forwarding table, which allows us to kind of track, which interfaces different devices or client systems reside on. So I talked about the packet flooding process. So a couple little notes about packet flooding. So it occurs when we don't know where the destination system resides, so which port on the device that the destination system resides on. So at that point, the Juniper device duplicates the packet and floods it out all interfaces, sends it out all interfaces. And that's done at 2 different levels, or 2 different techniques can be used to do that. It can use a layer 2 security policy to determine where to flood those messages, or it can use VLAN. So any ports that are in the same VLAN, it'll flood the message to all those ports. Instead of flooding a packet, the Juniper device could also use ARP messages or ICMP messages to locate a device and figure out what port that device is plugged into. So how this works is that when the message arrives to the Juniper device, it looks at the destination MAC address, compares that to the forwarding table to determine if the device is already listed in the forwarding table. Let's assume it's not. So at this point, what would happen is the Juniper device would send out an ARP message or an ICMP message, which basically is a request message sent out, and it'll send that out to all the ports. And then the receiving system would see that message and then reply to it. At that point, once the reply comes in, then the Juniper device knows where that system resides. So that's another technique that could be used. So it's either ARP messages or ICMP messages. So here we talk about some of the common fields that we find inside those ARP messages. So there's a source IP address field, there's a destination IP address, there's a source MAC address field, and a destination MAC address field that kind of contains the related information about the source system or the destination system. Now we can also have ICMP messages sent out as well to locate the computer on the network. And these are termed traceroute messages. So we can use these traceroute messages, which essentially are almost like little ping messages trying to locate a system. And there's a number of different fields that exist within the header of that ICMP message. So there's the source IP address, the destination IP address, the source MAC and destination MAC, but also there's a time to live value as well, which is set to 1. So all of those fields of information are contained inside the message. So in this demonstration, we discussed routing and forwarding tables on a Juniper device.